Here's problem number 1, labeling the boxes. The information that's important that we need to know is that we have 3 boxes. They're each labeled red, red and green, and we know that they are not labeled correctly. So whatever socks are in here, we know they're not all red. They're not all red and green for this one. They're not all green for that one. And that's important information. Our goal is to be able to go to one box, pull out a sock, and no matter what the color is, we can then deduce what colors are in all the other boxes. So let's think about this, and let's play this game. Let's play the if-then game. So let's say I start with the red box, and I reach into it and I pull out one sock. If it is red, so if I reach into the box labeled red and it's a red sock, then I know, because it can't be the all red box, we know this has to be the red and green box. No doubt about it. Now we have 2 colors left. We have red, a solid red and a solid green, and we know that this green can't be solid green, so it has to be red, and that makes this green. Now just right there, you might say, wow, I found a solution. This is great. I'm done. Except for you're not done, because you have to think about what happens if I reach into this box labeled red and I pull out a green sock. Because that could happen too. You don't know. So let's think this one through too. If I pull out a green sock from the box labeled red, and we know that it's not all red, we know that this, here's the then, we know that this is either green or red and green. We don't know which. And you might be tempted to stop right there and say, well, it's an either or, so we don't know, we might as well stop there. But it's generally worth thinking it through all the way, just in case something happens with the other boxes that exclude one of those 2 choices. So let's go ahead and think our way through. If I reach into the box labeled red and I pull out a green box, if it turns out that this box is green, then we know we have 2 other colors left, red and green and green. I'm sorry, red and green and red. And this can't be red and green, so we know that this box is red and this box is red and green. If I pull a green sock out of the box labeled red and it turns out that it's the red and green box, then we have 2 colors left. One is green, one is red. This one can't be green, so it has to be red. And then that leaves this one to be green. So our intuition was telling us, yes, this isn't going to work. If we go to the box labeled red and we know it's not red and all the boxes are labeled incorrectly, if we get a green sock, then we don't know. We've got too many chances, too many options here. So we don't know. So this is not a solution. Pulling a sock from the box labeled red is not a solution. Now I'm going to pause a moment and reset my setup, and then we will go check out what if we pull a sock from the box labeled green. Here I am reset. We know that the boxes are incorrectly labeled. If we reach into the green box and we pull out a green sock, then knowing that it can't be an all green box, that tells us the if green sock from the green box, then we know this has to be the red and green box. There are 2 colors left, solid red and solid green. It can't be, this box cannot be solid red, so it has to be green, and this box would have to then be the red. And if you think about what we just did on the previous part, pulling a sock from the box labeled red, if we pulled out a red sock where the color matched the label, then we had this same sort of setup. We pulled a green out of a sock that matched the label, so we knew it had to be red and green. When we pulled a red sock from the box labeled red, we knew that the box then had to be red and green. So this is called symmetry in math, in understanding proof or logic and reasoning. There's some symmetry between pulling the same color sock from a box labeled red and the same color sock as a box labeled green. You get the same sort of solution. So let's do if then for pulling the other color. If I go to the box labeled green and I pull out a sock and it's red, we don't know if the box then is red or if it's red and green. And so we're back in symmetry with the same thing we did before. If this one's red, then we have two other colors left, two other boxes left, red and green and green. So this can't be red and green, so this has to be red and green. And this can't be green, so that has to be green. If our box that we've just pulled out from is red and green, then we have two colors left, red and green. This can't be red, so it has to be green, and that leaves this one to be red. So again, the same sort of symmetry, we don't have a solution here because we don't have a definite answer. So I'm going to pause and reset my screen, and we will check the answer for the other one. So now we're reset, and we're going to look at pulling a sock from the red and green box. You might be tempted to say, well, I just showed there's no solution here, and I just showed there's no solution there, so the solution has to be here. Don't give in to that temptation. You need to verify your solution. Don't assume that a solution has to exist. You have to show it exists by actually showing that it works. It's quite possible that you could not have a solution to this problem at all. So never assume that there's a solution and therefore it has to be here. We have to show that it works. So the first thing we'll check is if when we pull a sock out of the box marked red and green, if we get a red sock, then because it can't be a red and green box, we know that has to be the red box. We have two colors left. We have the red and green mix, and we have the green. This can't be green, so that makes this green, and that makes this red and green. If we reach into the sock or the box marked red and green and we pull out a green sock, then we know that the box can't be red and green, so this box has to be green. There are two colors left, red and green and red. This can't be red, so it has to be red and green. And this has to then be red. And now we see a solution. If we pull any sock from the box labeled red and green, then if it's red, then we can identify all three boxes. If it's green, we can identify all three boxes, and there's our solution. Notice there's some symmetry going on here too. If this is red, then that's red and that's green, and that's red and green. If this is green, then that's green, that's red, and that's red and green. There's some balance the way that the whole thing works. So recap what we have. We walked through the steps. We said, what if we pull this? What if we pull that? We checked to see that there were no solutions for red and for green. And then when we said, all right, we didn't find any solutions, then we assume there's a solution there, but we really can't assume that because we have to show that there is a solution. So we played the if-then game, and we logically stepped through all the choices, and we saw that there is a solution.